Now, in this video, we want to look at properties of logs. The first thing that we want to start with is being able to go between a logarithmic function and an exponential function. We can do this because they are inverses. So since logarithmic and exponential functions are inverses, we can change from one to the other. All right, all it's going to be doing is taking the base of the exponential, turning that base into the base of a logarithmic function, and as all inverses do, switching the x and the y's position. All right, so let's try a couple where we go from exponential to log, and then we'll try a couple where we go from log to exponential. Let's look at this first one. So the first thing that we want to do is we notice that the base of the exponential function is a. So that's going to be the base of the log function. All right. Then we are going to switch where the 24 and the 4 are. So the 24 is going to come on the side of the log, and the 4 will go to the other side of the equal sign. It's just that simple. All it is switching the x and the y's location and making the exponential's base become the log's base. Right? Let's look at the next one. W is the base of the exponential, so it's going to become the base of the log. K and Z are going to switch locations. So Z is going to come over here with the log, and K will go on the other side of the equation or the equal sign. All right. So the next one that we want to look at, we've got the letter E is our base. We're going to say log with our base E. I'm going to switch. It's going to be 17 equals 5 now. All right. All about switching because they are inverses. We're going to do the same thing when we go from a log to an exponential. We want to locate the base of the log. It's going to now become the base of the exponential. And I'm going to switch the location of the x and the y values. All right. So let's do it. I see I've got a base of an a for my log, so that's going to become the base of the exponential. And I'm going to switch, so now it's going to be a raised to the 5th power equals 7. Okay, looking at our next one, I've got a base of a 9. So the 9 is now going to be the base of the exponential. I'm going to switch. I'm going to raise 9 to the 8th power, and it's going to equal k. Okay, last one. Make sure we got it going on here. I'm going to have a base of b. It's going to be the base of the exponential. I'm going to switch. So the g is now going to be the exponent. The w is on the other side of the equals. So the first thing that we want to be able to do when we think about properties of logs is to be able to look at the property that it is an inverse of exponential and be able to rewrite exponentials as logs and logs as exponentials. So the next set of properties that we want to look at, I've kind of compiled them all here in one kind of big grouping just so you can see all the ones that we're going to look at. But we will look at them separately. Okay, the first group that we're going to kind of focus on are the properties up top where we are going to look mainly at being able to cancel off and simplify because we have the same base. All right. Then the next group of properties that we want to look at, typically they're called condensing and expanding properties. We've got what we call the power property, we've got the product property, and we've got the quotient property. So these properties we'll look at as well to be able to help us simplify log expressions. Okay, but here they all are kind of in one grouping, and we're going to go through each of them separately. All right, so two of the first ones that we want to look at that were kind of in that list on the last page is we want to look at these two that in general have same bases that will cancel. All right, so what I mean by that is the base of the exponential and the base of the log are the same. So I notice here I've got an a for an exponential function and a for a log function. All of that's going to cancel, and I'll be left with just m. Okay, I can do the reverse where I have a log base and an exponential base. All of that cancels and I get just r. Okay, so the idea here is that if they have the same base, meaning I have a log that has a base and an exponential with that same exact base, they will cancel. All right, so let's look at a couple examples, see how we can simplify them, whether it's written as a log or an exponential. Okay, so here we've got an exponential base of 2, a log base of 2, so those would cancel, and my answer would just be x. Okay, we're not looking for a single number here sometimes. We're just wanting to simplify it, get it to an easier form to look at. All right, so looking at the next one, we have a log with a base 7, an exponential with a base 7, so those cancel, and I'd be left with just 4x. All right, similar on the next one, I've got an exponential with a base 9, a log with a base 9, so my answer would be 8. So looking at this next one, we see that there is no base. So you're wondering, well, what am I going to do here? Because how are they going to match? But remember, when there's no base, the property is that there's really a 10 there. We looked at that base the other day. So this really, same thing, bases cancel, leaving me with a 4. Similarly, on my next one here, I've got a log with no base, which we know is a 10. So I have to remember those properties or those just kind of ideas from the other day. So now that I have a exponential function with a base 10 and a log with a base 10, I'll get 9x. All right. So this next one, you're thinking, well, wait, there's no base of 3. So it's not one of these, but one of the other properties that we looked at, I'll bring it in right here. So one of the other ones that we looked at is this idea of that if we have a log, any base, and our base of the exponent is a 1, then our answer is automatically 0. Okay. What that next one would look like, let me just show you here. Let's say I had log 5, 5. All right, so this property means that I have a 5 and a 5, so they cancel. You're like, oh, there's nothing there. And it's just like in multiplication, when there's nothing there, it's a 1. It's not a 0. I get a 0 on this property here. Okay, when I have a 1 as the base. I get a 1 when the bases match up. Okay, so we also have those two properties there. So again, we want to memorize those properties of same bases cancel. All right, so our next set of properties, they are used to condense and expand logs. Now, these are individually pretty simple, but when you put multiple things together, you got to really think about what's happening. Okay, so we've got the individual properties here, meaning that in a condensed form, so I know that it's condensed when I have only one log. Okay, so here I would be condensed, condensed, condensed. All right, I would be expanded if I have multiple logs. So see, I have 1, 2 logs there, so I'm expanded. Okay, so this one you're like, oh, there's only one log, but there's a number multiplied in front. And I know, for example, if I say, okay, I want 5 times 7, that means I want 5 of the number 7. So that means it's really on there more than one time. Okay, so even though it looks like that last one doesn't have multiple logs, it does, because there's a number multiplied in front of the log. Okay, so these over here are our expanded form. That was a weird E. And these on this side is the condensed form. All right, so we want to be able to go back and forth between the two. Okay, so just kind of summarizing, if I really think about the operations as easiest to most difficult. So if I think about addition versus subtraction, well, I learned how to add first, so addition must be easier. Same thing with multiplication and division. Multiplication is easier than division typically. So they put the two easy ones together. So in a condensed form, I'm multiplying. And in an expanded form, I'm adding. So addition and multiplication go together. Okay. I'm also going to put division and subtraction together. So in a condensed form, my division will turn into an expanded form of subtraction and vice versa. Okay. So those seem to typically make sense. Add turns to multiply, multiply turns to add. Subtract turns to divide, divide turns to subtract. So those kind of go together. The next ones I have to think a little bit more advanced with. So on this one, it's that I have an exponent turns into multiplication in front. We call that a scalar multiple. Okay, it's different than I'm multiplying the two numbers. I'm multiplying a number in front of the log. So this here should look different than this multiplication up at the top. Okay, so exponents turn into number in front being multiplied. Number in front being multiplied turns into an exponent. Okay, so those seem very vague and just kind of like, I don't really know what she's talking about. So let's look at some examples and see if we can see what's happening. Okay, so in these first examples, what I want to do is I want to write it as a sum or a difference. What that means is it is condensed, so I want to expand. So that means my answers should be in adding, subtracting, or scalar multiples. That's how I should see all of my answers. Okay, so let's see if we can turn that into it. Now, every time we do one of these operations, we're going to give it a log because when we expand, it has multiple logs. I write it every time. Okay, so the first thing that I want to do is I'm going to look at what is happening. So I see a 3, I see an X, I see a Y, and I see a W. So that to me says I should have 4 logs. I'm going to have a log sub A 3. I'm going to have a log sub A of X. I'm going to have a log A of Y. I'm going to have a log A of W. Okay. So what that means here, I don't want you to think that that 3 is connected to the W. Okay. So now what that means is I've got 1 for everything. I need to now go back and decide, am I adding, subtracting, or putting a number in front? Okay, so let's look at it. 3 is getting multiplied to x squared. So that means I'm going to be adding the 2. Okay, because multiplication turns into addition. Now I notice I've got an exponent here. So exponents turn into scalar multiples. So I'm going to put a 2 out in front because I had a 2 as the exponent. Okay, and then that x squared is being multiplied by the y. So I'm going to put an addition sign here. And then that y is getting divided by that w3, or that w cubed, sorry. So I'm going to subtract because division turns into subtraction. And then I have that cubed, which will turn into a 3 of a scalar multiple. And that would be my answer. So you're like, well, that looks crazy. I agree. It does. It looks like a very expanded form of that log. Okay, so let's try another example. Looking at this next one, I want to first identify what I have. I have an x squared, I have a 2, and I have an x plus 1. Okay, so that means I'm going to need 3 natural logs. I'm going to have a natural log for my x. I'm going to have a natural log for my 2. I'm going to have a natural log for my x plus 1. All right. So now I'm going to determine what else I have. I've got an exponent of a 2 on that x, so I'm going to need to put that number in front. It's getting divided by, so I'm going to have to subtract. That 2, nothing else with it. Now, this x plus 1, even though it's getting multiplied by the 2, it is still being divided by, it's in the denominator, so I'm going to subtract, okay? Subtraction always wins. So even though I was multiplying, think about it here, I've got the division is going to turn into subtraction. The multiply is going to turn into add, but a positive and a negative make a negative. So you can also think about it like that. All right, so now I've got a 4 here. This 4 is going to go out in front. So that would be my simplified form. Okay, even though it doesn't look simplified, that's what it is because the directions where I wanted to write it as a sum or difference. Okay. Now let's look at what we would do if it was already expanded and we wanted to condense it. So now what I want to do, I want to condense. So in my answer, I should see multiplication, division, and exponents this time. And I should only have one log. So I'm going to go ahead and write my 1 log base 2. Okay, I'm going to have a 7 that's going to get multiplied by that x. That's going to get divided by that w to the 5th. Okay, so see what I did? I took that number that was in front. It became the exponent here. I turned my addition into multiplication. I turned my subtraction into division. Okay, let's look at our next one here. I need to write 1 natural log. This 6 is going to come up here to the x. So I have an x to the 6th that's going to get multiplied by that w squared that's going to get divided by a y to the 1/5. Okay, now I'm going to talk a little bit about exponent properties because typically, like for me, this would be a perfect answer. However, there is a little exponent property that says anytime you have a fraction, it comes out as a root. Okay, so this instead of saying 1/5 would really be the 5th root, so that's a little 5 there, the 5th root of y. So what our answer really would look like here is the natural log x to the 6th w squared over the 5th root of y. Okay, so it's just when there's a fraction, it becomes a radical sign. Okay, whatever that denominator is, you put it out in front. So I didn't know if we kind of remembered that exponent property or not. But that's how I'm going to condense and expand those expressions. Expanded form, I should see addition, subtraction, and scalars in front. Condensed form, I should see multiplication, division, and exponents. So now we've looked at all of the different properties. Here they are just again kind of put all together. Maybe this is an easier way for us to look at them. But the main idea when you think about a property of a log is to be able to somehow simplify the log function, whether it be because we're going to rewrite it as an exponent. Maybe it's we've got an exponent and we want to rewrite it as a log. Maybe we want to be able to cancel some things because the bases are the same. Maybe we want to be able to condense or expand something so that eventually the whole goal of these properties is to eventually be able to solve logs and exponential functions. Now, we won't look at that this year. That'll be more of a pre-calculus topic, but we're just kind of setting the foundation to be able to manipulate these logarithmic expressions and equations later.